Good afternoon, everybody. Welcome to Pipeline Modernization, Session 1, the build stage. Today we have the Release Team CEO Shawn Doyle, also author of DevOps Overture, and GitLab guru Kurt Dusek. If you have any questions for either one of the presenters, you can put them in the chat and we'll address them at the end of the presentation. So I introduce Shawn Doyle.
All right, thank you, Keith. A little bit about myself. I'm Shawn Doyle, as Keith just said, but I'm the co-founder of ReleaseTEAM. I've been running ReleaseTEAM, and we founded it back in '99, so this is our 21st year. I just published my first book late last year, and a kind of an introductory book into DevOps and helping people learn what DevOps is and understanding what their role would be if their organization suddenly added DevOps to their company.
Cool. Hi, everyone. Thanks, Shawn. My name is Kurt Dusek. I'm a senior solutions architect with GitLab. Prior to joining GitLab, I was a software engineering development manager, and I ran a tools team for a cable company. We used GitLab as part of our development process. So I've operated GitLab, I've sold GitLab, I've consulted around GitLab, and I'm happy to be co-presenting with Shawn. If you're not familiar with GitLab, it is a source code repository tool at its core, similar to GitHub, and it's based around Git as a version control tool. And it really strives to be a single application and application platform for building all of your additional DevOps tooling on top of and running your automation out of. So the idea behind GitLab is that it's able to bring in all these different aspects around source code management and issue tracking and CI, CD and automation and container registries and all that sort of stuff and roll it into one platform that gives you more than just the sum of its parts by allowing everyone to collaborate and be unified by a single authentication model, by a single application model, and all sorts of other aspects. You have, you're enabling collaboration and transparency inherently just by using one application as part of your development process. Oh, Shawn, I think you're muted.
I'm still on mute. Yeah, I'm going to do that multiple times today. I planned on it. So who is ReleaseTEAM? So ReleaseTEAM is a professional services company that also partners with a lot of different software vendors in the DevOps space. We help customers modernize their development environment, bringing people into CI/CD in the world of DevOps. I won't read through all this line by line, but this is what my marketing department likes me to talk about when we do webinars. Some of our happy clients, another thing I've been twisted, my arm's been twisted to throw that up there. Not that hard, but anyway. So this is a first of our series on pipeline modernization. We're going to focus more on the build stage for this particular one, and we'll talk about other stages of a pipeline and in future webinars. So before we kick off, some definitions. Everyone's probably heard of what CI and CD is. Here's where ReleaseTEAM defines where CI and CD is, and the one point I want to make is CD could be one of those two. So here's a quick graphic that explains that a little bit better. So when you're talking about continuous integration, you're usually talking about the pipeline through the release phase. So you've done your compile, it's done some sort of package, it's done some sort of initial test, and it's placed out someplace for release for another team or another environment to grab and then do something with. Continuous delivery includes that something. So you're not necessarily sending it to an operational site, but you're delivering to some sort of system, regardless of what type of software you're developing, whether it be embedded or some sort of web-facing system. And then deployment means it's going live, where customers are seeing this at the end of the pipeline. So typical stages in a pipeline, I won't go through this in too much detail here. We're going to focus on the build for today's session. But these are other things that your typical pipeline will flow through. Not every pipeline will have these, and some pipelines will have more. But these are things that we can dig in deeper in future webinars. So what's in the build stage? One of our favorite stages. Typically when you're looking to improve your pipeline, one of the first things you want to look at is, what's the underlying architecture of your pipeline first, which we'll talk about in another webinar. And this one is we're deep diving on a build stage. So once you've decided on what tool you're going to use for your CI or your CI/CD, start looking. I'm assuming most people already have some sort of pipeline in place, but you start looking in what makes up your build stage. And it's not just your CI tool at this point. It's all these other underlying tools that you need to look at. Specifically, your SCM tool. What are you running for software configuration management? This typically could be Git or Subversion or Perforce or ClearCase. Naming all the favorites there. So you need to understand what you're using. So all these things together, your SCM, maybe some sort of database, you're pulling in some tables or something, or maybe you have to sync some database changes up with your code changes. What are you using to manage your containers? What are your containers? Are you using containers? What are you building on? You need some sort of build server or set of containers to run your compile or your build stage. Are you using an artifact manager, something like a binary manager like Artifactory or Nexus or something like that? Are you using dependency manager like Maven or Gradle or something like that? A configuration manager, tools like Chef, Puppet, Ansible. And obviously your compilers and linkers. What are you using there? And you need to look at all of these, because if your build stage, if your build stage is where you've decided that we want to improve in our pipeline, it's not just your CI tool that could be slowing things down. It's all these underlying tools that make up your build stage. Now, this is pretty much what I just rambled on about. But when you're looking at what you can improve in your build stage of your pipeline, you need to break down all the steps. What is your build? What is the build stage doing? Where does it interface with one of those tools in the previous slide? What can we improve? What needs to be updated? What can't be updated? What can be, what can you do with all this? So when we go in and look at pipelines, when we're doing professional services for our customers, we take a look at their pipeline. Now, everyone's pipeline is someone's baby, whether they inherited the baby or they created the baby themselves. Every baby has a degree of ugliness. Now, you never want to go in and call someone's baby ugly on day one or ever, really. But but you need to understand all these babies are ugly, and what can we do to make to beautify this baby? Are we just worried about speeding things up? Are we worried about making sure that things are consistent? Are we worried about making things more solid? I missed the word for that, but basically improving quality. So I'm gonna get that back in your build step. So these are all the different things to dig into that goes beyond what people normally would think of improving their CI tool. So once you go through and you've identified what steps make up your build stage, and you've improved what you can, you've maybe upgraded to the latest versions of some compilers, or swapped out, an aging tool for a newer tool. Maybe it's the underlying build servers that you upgraded or things like that. Need to identify what the bottlenecks are. How do these things tie together? So your build stage may have, dozens of steps underneath it. How do those steps how do they relate to each other? How do they interconnect? And you start looking for the bottlenecks in that pattern. So for example, we had this one really large project that we were working on for a client, a big monolithic tool. And in their build stage, they had 15 compile steps. So each one of them was a separate component. They were doing things in serial. So their build was roughly taking, let's see, I can't remember exactly. I think it was, about 10 hours or so to build from one component all the way to the other. So the obvious thing is, well, can we build these things in parallel? And looking at that, their largest component that wasn't dependent on something else was 6 hours. So we could take the build down, from 10 to 6 just by moving things that can be moved into parallel. But then you can look even deeper and say, well, why do these components take so long to build? And dig into that. And in this one particular one, the linker was taking a lot of time to build, or not to build, but to link, because that's what linkers do. And by moving around where the linker was, and allowing it to do some incremental steps for some components and not allowing it for other components, we're able to shave roughly 45 minutes to an hour off each one of those components, and ultimately getting the 10-hour build down to about 4 hours just by rearranging how the steps work inside the build stage. The next thing to really be concerned about is of all the things that make up your build stage, how much is technical debt, and are you taking care of the technical debt? So another similar client that we had 72-hour build times, and when we took a look at that, the main reason for 72-hour builds was manual handoffs. And the majority of manual handoffs were because their build farm was not consistent. They had, I don't know, more than a dozen machines to do their build, but rarely were two systems identical. So what ended up happening over time, and this is a project that was more than a decade old. So over that decade, certain components of their build would only build on certain build hosts, even though the build hosts were reported to be identical. They obviously weren't, because component A built on 3 of the build hosts, and component B built on a different 2, and so on. So when we went in and we suggested, well, one of the first things we should do, because this is obviously technical debt, it's a part of technical debt called configuration drift, where at one time all these machines were probably pretty close to each other, and then over time, a request was made to upgrade some underlying dependency on one machine, and it wasn't done across all the machines, or it was done differently across different machines. And then now the machines aren't the same, and things don't run the same or compile the same across all the machines. And certain development teams have confidence on some build servers and not on other build servers. So you need to solve the configuration drift in a situation like this, because it becomes technical debt. So then you have another newer component for a new version of your product, and it requires an updated dependency. And well, now we can't update the dependency across all our build servers, because build servers 1, 2, and 3 require the old version of Python to do something, or the old version of some system libraries. So addressing or not allowing or trying to nip in the bud the configuration drift kind of keeps you out of technical debt. This client was clearly already past that and deep into technical debt because their builds were 72 hours long because they had to build things across different machines, and it wasn't automated, and they had different teams letting the other teams know that, hey, my piece finished, so you can start your piece. So one of the interesting arguments we had with this particular customer is when we raised this, development was all, oh yeah, that's great. We shouldn't be doing this. That's a great find, but a terrible situation. And we brought that up to their IT team that managed these, and they would have none out of it. There's like, if there's a problem with one machine, send in a ticket and we'll redress it. And we had to point out, well, that's how you got into configuration drift. It's like, do you want a configuration drift? Because that's how you get configuration drift. So eventually we were able to work with the SA management or the IT management at that company. We were able to move them to a more modern build farm where at least they had golden VM images that they could deploy and redeploy anytime one became suspect of configuration drift. Whoops, I went a little too fast. All right, so real quick summary before we open this up, because we'll really want this to be more interactive. You take a look at the pipeline. The very first thing, I kind of jumped over this, lost my pacing on that at the beginning of the thing, but you really want to use a modern CI/CD tool that supports infrastructure as code. So something where you can write the code for the pipeline. It's saved in your version control system. You activate it or initiate it from your CM system, and it spins up the pipeline. And then goes out and does all the stages in your pipeline. After that, then you need to look at, for each stage, and we did a deep dive into the build stage, what can you take advantage of their upgrading? Are you still using something that is meant for 1990s technology that are maybe it's client server and you haven't upgraded your servers in forever, or have you already gone to something like Git, but might need to upgrade your Git enterprise solution? Are you using the latest ones? And then looking at your overall pipeline or in your stage, can you eliminate a step inside the stage, or can you combine them, or what can you do to speed them up? It's not always as simple as, hey, let's do all the steps in parallel. But that's one of the things you should look at, is how much of this can we do in parallel inside a particular step. And then once we're done with that, look at the bottlenecks. Every system has a bottleneck. Pipelines by definition are going to have bottlenecks. You need to identify the one that's causing the most problems, fix that. Hopefully it's the one that's further down the stream from everything. I like to fix things at the end of the stream and work my way back up to the source of the stream. Fix that bottleneck, identify the next one, put a plan in place, fix that, find the next one. You'll never finish. There'll always be a bottleneck, but you want to eliminate them, or constantly be eliminating them. Reduce technical debt. Any good agile organization should be focusing upwards of 20% of each sprint to attack, reduce, or avoid technical debt. So that could be things as, upgrading servers, upgrading software, upgrading tools. And overall, we don't think anyone's babies are ugly. But everyone's pipeline is someone's baby, whether it's the person that we're working with to try to improve them, or it's the organization's baby. So any questions? And Kurt, feel free to jump in.
Yeah, just to piggyback a little bit on what you were saying, in terms of what we're talking about with technical debt and bringing people together, oftentimes you have a big, broad organization. So you may have your development managers, your individual developers, your stakeholders, your leaders. And the idea is that when we're talking about things like bottlenecks and things like why is all this complexity creating problems, is it's much easier to mitigate those problems when you're within a single tool. And so the idea is that we can see end to end, hey, when we make a commit here, why does it take so long to be released into production? Whether that's the automation taking a long time, whether that's the organization itself taking a long time, in terms of we have a bottleneck not in the technology, we have a bottleneck in the approval process where the person who is the gatekeeper on the code may not necessarily be aware of or understand the priority of certain requests that are made of them. So bottlenecks take place not only at the technical level, but obviously at the operational and organizational level. And the idea behind GitLab as a tool is that it helps to smooth out both types of bottlenecks. So you have as many people working together and they have maximum visibility on everything that's going on, and they can turn down that visibility if they're not necessarily interested in seeing all these different moving pieces, but they can still work together and collaborate on all these different issues and ultimately get code out the door faster. Looks like there's a question in the chat. Steve, can you verbalize? Was that question for me or for Shawn, or is it just for anybody who wants to take it? Shawn, I'll let you lead on that question. If you have any examples of technical debt, and I can jump in afterwards. Oh, Steve can't unmute. Shawn can unmute. Anyone who can answer. Shawn, do you want to lead off on that one?
Yeah, I was just given the authority to unmute myself. I'm not sure how that toggled there. I'll find out after the meeting. So the question is examples of technical debt and how you've overcome them. Well, most of the technical debt that I've run into at customer site, we first bang our head against the wall for quite a while. When we're done with that, then we start trying to address the technical debt. One example, and there may even be some people on the call that will be able to pick out which company I'm talking about, had a large satellite system. I'll leave it at that. That was built or not built. It was designed in the late 80s, late 80s, early 90s. At that time, SGI had the best video graphics of all systems. And so they based their entire architecture around using SGI machines for the display. It is now, obviously, 2020. They still have to compile on SGI machines for the display because their customer refuses to pay for the porting of that code to something like Linux or anything that has a modern video graphics card, which is pretty much everything these days. Our cell phones have better graphics than SGI's did back then. So because they still have to compile on to this day on SGI, they can't upgrade their version control system. Since they can't upgrade their version control system, they're stuck at a particular version of Make that came with that version control system. Nothing else runs on SGI these days, so you have to compile your own version of Jenkins or Hudson to get a pipeline to run on that. So this technical debt is causing them to have a tools team that has to build their own versions of a lot of common, usually, I guess, COTS products, vendor delivered solutions, because they have to support this old operating system. So that's a really bad example of technical debt. The rest of the project would love to be using modern tools, but the entire project can't because of this one component that has to compile on SGI. how do you overcome that? This particular thing, you need to address the underlying requirement of why, if your customer's not going to pay for this, you got to spell out how much is this actually costing us, and can we just incur the cost as a development organization to fix this problem so we can move forward. And ultimately, for the amount of time that their developers and their the organization is spending to get around this lack of funding is costing them more than just addressing it and dealing with it. So that's probably an extreme of example of technical debt, but it usually goes into the pattern that you don't bother to upgrade a tool, and then it just has reoccurring, or not reoccurring, but cascading problems after that. So, take my favorite tool, ClearCase. We don't upgrade ClearCase. We're stuck on ClearCase. Well, my what do you want to call it? So say my pipeline tool doesn't work well with ClearCase. It expects something that's Git based. So now my code review tool doesn't want something that old, and it just cascades. Like my developers are like, we want to use this new peer review tool. Well, the new peer review tool is only 2 years old, and it only supports Git. So now I can't go to that because something else is tying me back. The same thing goes for operating systems. So my IT organization doesn't want to upgrade us past Windows 7. Well, none of the new tools support Windows 7. I just had to upgrade, just pick on a vendor. Let's pick on Sonatype. So I want to deploy the new version of Nexus Lifecycle. Well, I can't because Windows 7 is no longer an supported operating system. So that's basically technical debt.
Yeah, I'll give another perspective if you want another view. So from back when I was running dev teams, we'd have, hey, this is a long-lived application, and we've had a revolving door of architects and developers imposing their style and doing, whatever they're doing to advance the application from your stakeholders, right? Stakeholders are demanding features. When is this going to be ready? We need it ready as soon as possible. And so that can sometimes compromise the software itself. And then you end up getting the situation where your stakeholders are unhappy. Hey, this app is really slow, or when we want to add new features, it takes a long time. Why is that? And so they're starting to see the effect of technical debt, right? So the first step is don't create any more technical debt. As your stakeholders are coming in and demanding new features, instead of, there's that fork in the road, whereas as your developers may say, well, if we do it the right way, it's going to take 2 weeks. If we do it the fast way, it's going to take 2 days. Your stakeholders are always going to say, do it in 2 days. And that discrepancy between that 2 weeks and that 2 days, that is your technical debt, right? When you're making all these, you're cutting corners to hit some arbitrary deadline or goal that's certainly necessary for maybe the business stakeholders and the business owners, but it's going to come back to haunt you, right? It's just like you would swipe your credit card to buy something that, well, you could save up the money to buy it, or you can swipe your credit card and pay down that debt and the interest to that debt over time. So the first step is, number one, don't create any more technical debt, and let your stakeholders understand what technical debt is. That's going to be part of it. Is they don't understand, hey, there's the geeky guys are doing something behind the curtain and we don't understand why it takes so long. So part of it is really expressing what the challenge is, and they may not understand what you're doing, but they should understand this is why we're in this situation. Now, for us to resolve it, first of all, we're not going to create any more technical debt, and we're going to have to pay down that technical debt by taking away from your feature velocity. So rather than rolling out as many new features as you want all the time on demand as soon as you can get them, we have to reallocate our development resources to managing that technical debt. And how you do that, well, there's different approaches. It's porting the application to another framework or language or architecture, or incrementally improving it at a functional level. There's different ways of how you would implement that. But at the top 2 levels is really introducing, hey, we have to mitigate any debt that we create. We don't want to create any more debt. We need to let our stakeholders know we have a heavy burden of debt. And that's kind of the source of a lot of the the problems, if they're bubbling up to the user level or the stakeholder level. This is what the challenge we're facing. And then understanding, in order for us to resolve this, we need a certain amount of that executive buy-in to then go in and re-architect or improve the pieces that we need. And then it does raise the question of, hey, how did we get in this situation in the first place? Is it our tools are not great? Is it we're using the wrong piece of software or the wrong framework or the wrong language for the job? Is it, hey, this is a legacy app that we're having to drag, into 2020 that should have been deprecated 10 years ago? There's always those types of things, but it's generally the approach that I take is transparency. There's always that, I feel like, that effort where you have to lay your cards on the table to your stakeholders and say, look, we absolutely want to support you. We want to deliver the things that you want. We want to give you all of the things that make you happy, but we can't do that with this burden on our back. And so this is the plan we've laid out. We're going to slow down your development velocity a little bit, but we're going to give gains on those long running reports that take 2 or 3 minutes to get data out. We're going to solve that problem. And if you can solve that problem in a short way, your stakeholders say, wow, that's great. This app is so much better. What did you guys do to fix it? Well, we did some computer black magic. And if you let us do a little more on this sprint, we'll get it a little bit faster for you on the next time around. So it's going to be kind of an incremental approach of trying to get those gains out. But there's always the technical approach to do it. And then there's the part where you need to get that executive buy-in to do it.
Yeah, I fully agree. Often when I think technical debt, I think tools, because I'm a tools guy. But it's definitely how you've coded or architected your tool, or not your tool, but your product. So, but yeah, and you get these product owners that just want the new feature as soon as possible. So yeah, there's always the easy way and the right way.
Yeah.
We had some feedback from Grace Marie Hopper. She says, we often just look at the cost of doing something when we should also look at the cost of not doing something.
Yeah,
I don't know if Grace is on the call, but she did say that.
So we have another question here. They said it seems like as we're looking into modernization, it could take more time than my small team has. If we only have a few resources that would be available to work on this, what advice do you have on how we can still start the process?
I think Shawn will say call release team.
Well, yeah, but otherwise, like part of if you're agile, and I think most people at least say they're agile, if not already being agile, you should be spending, like I said, about 20% working on technical debt and upgrading your pipeline and speeding things up and making things more DevOpsy is technical debt. And you should allocate 20% of your small team to addressing that per sprint. It's I don't want to come up making it sound like that's an easy answer, because it's definitely hard to implement that. But you need to convince the product owners and on your Scrum teams to address that and add that to their planning. Because it goes right to what Kurt said. If we have to change our velocity to address that, we need to do that. So.
Yeah. Piggybacking
also,
on that.
I just had a comment on that too. In other Scrum teams, sometimes every now and then we just devote a sprint to, hey, we're going to do clean up technical debt. So there's no bug fixes. Well, we might still have some bug fixes, but no new features. We're going to just spend time and reduce technical debt. And we're just going to sacrifice a sprint for that. So that's another option.
Yeah, absolutely.
And this set of questions leads me to a good segue to plug another set of meetings that we're going to start up next Friday. And we're going to start a series of just informal Ask Me Anythings where we can all just join. They won't be a presentation, but we can discuss things like this in this type of forum.
Yeah, another thing to add around how to get out of the rut if you're struggling with resources and you're overloaded. I mean, in a nutshell, baby steps, or really just trying to, if you've read the book, either why am I not thinking? The Phoenix Project or one of the Unicorn Project, which are books about DevOps and how, like, kind of novelizations of how organizations run their IT departments. But one of the concepts in there is improving the work is as important as the work itself. So if you have a developer on your team and they spend, out of an 8-hour day, 2 hours doing something that could be automated, whether that's running automated tests or delinting something or doing something like that, that's 16 hours, or that's what, 10 hours a week, every week. And if you can scrub that task off of that developer's job, then that is going to build your momentum. And so that is, I think it kind of goes back around to Shawn was talking about bottlenecks, is there's small things that it's like, oh, we don't even really think about it a lot of times. Which is like, oh yeah, I've got to do this, or I've got to build this app or provision this server to then copy my code over and then test it. And if it doesn't test, then I've got to fix it and then redo that. And that's super time consuming. And we, it's very likely that organizations fall into these rituals and habits. And it's like, oh yeah, I just do this because I do it. It's kind of tedious, but what are you going to do? Like, nobody can come along and fix this until they fix it. And so that's the thing, is as an organization, it's stepping back. It's sometimes saying, like, how do we get a little bit of perspective in here, and saying, like, what are the small things we can do that saves everybody time, or that saves a lot of people, from having to do this manual task and the automation. If we spend, back kind of to your point, Mark, it's like, hey, what if we spent, kind of on that technical debt, let's spend a sprint, or let's allocate, our DevOps guy or whomever to just putting in as much automation this sprint as we can for the broader team. And then what does that give us? Does that give us 2 hours of productivity a week, per person, or 5 hours a week per person? And if that becomes, say, a monthly ritual, if you say do week-long sprints, and you're doing one sprint a month just at automation, 3 months from now, you'll have significant gains, right? So if we start this at January 1, and if we come in March 1st, or April 1st, and say, hey, we've been through this process 3 times. Now we're able to do things in 3 hours that used to take us 5 hours. And that's great, right? And we can start to compound that, right? That eases that burden off of your back as it is there. And that's where things, where again, it starts to increment, where there, just as a nutshell, we're, basically improving the work itself improving the work is as important as doing the work itself. And when you apply that to how things are being done by your development team, it's easy to start to see how that momentum starts to compound, and a slow but sure way of digging out of those ruts.
Okay, we have another question. We have thousands of build jobs hitting our Jenkins server right now. What would be your suggestion on how to improve this?
Stop using Jenkins. I'm biased. The problem with Jenkins is that Jenkins was more or less the first kind of widely adopted approach to CI, and the architecture has changed, right? Where everything flows into the Jenkins server, Jenkins does everything and then pushes it out. Well, you have a bottleneck there. If the Jenkins server tanks, no work is getting done. If the Jenkins server is conflicted, no work is getting done. So you're kind of always having this bottleneck of having to manage this Jenkins server. The approach to GitLab CI is different. Number one, it's decentralized, so there's no server to go down. Second, it's also localized, so you're not using third-party plugins and kind of outside tools and things. If you can run a CI command in Bash, then you can turn that into automation within GitLab. So it's a much less kind of opinionated proprietary approach to CI. That's how I would do. The whole Jenkinstein server thing is a very common thing. I mean, Jenkins even admits to it, like, hey, there's suboptimal ways, and sometimes you dig yourself into this hole. Good luck digging your way out of it. To me, the solution is really starting to re-architect what it is. And if you're going to re-architect, then it's potentially time to look at a next generation solution, or iterating to something that's maybe a little more modern around CI. Shawn?
Yeah. No, I would echo a lot of that. But for our approach, we would go in and take a look at what's going on with your current system, your as-is system, and then come up with the options of how to improve it. So I'm assuming, since they asked the question, that 1,000 builds a day is too much for them, or too much for their system. Otherwise, I guess they wouldn't be asking the question. And we would look to see, okay, what's generating that? Is that realistic given the size of the development and their schedule and things like that? What are their pipelines doing? Is it CI or is it CD? Are they spending a lot of time in their build environment or the build stage? And we look at that. Depending on what's going on with your Jenkins environment, an upgrade to GitLab may be the number one option that we give, but we would do a deep dive to determine that that was the best direction going forward. It may be that your build system can support 4,000 jobs a day, and you're just concerned that you're seeing a lot of stuff in your log files and your build output that you're thinking of thousands of overload. Yeah, we would have to take a look at the entire build system and come up with the solutions that make sense.
Okay, are there any other questions? Thank everybody for attending. Kurt, Shawn, thank you for your time and your ingenious insights. All attendees, you'll be getting a follow-up email with a link to download your free copy of the book. And if you want to rewatch the video or get a copy of the slide deck. Thank you for attending, and have a great day.
Thanks, everyone.
Thanks, y'all.